the Electrochemistry Lectures Part 4 under the Chemistry Lecture Series, and I am Dr. Anima Upadhyay. In today's lecture, we will learn about the determination of single electrode potential using the reference electrodes such as standard hydrogen electrode and Calomel electrode. As we all know that when we immerse a metal strip or a wire in the electrolyte of its own ions, it develops a potential at the interface, and this potential is called the single electrode potential. So if we are given with an electrode whose potential we want to determine, we can couple it with the reference electrodes such as SHE or Calomel electrode because their potentials are known and are constant. So the measured potential will be the potential of the electrode under test. Now let us take the examples and learn it further. So in the part 4 lecture on the electrochemistry, as I have told, we will determine the single electrode potential of a given electrode. When we will couple the electrode under test with the reference electrode, it will develop some potential in its ionic solution, and we can measure the EMF of the cell using the reference electrode. So the measured EMF of the cell will be substituted along with the potential of the reference electrode in the formula E naught cell is equal to E naught cathode minus E naught anode. And with the help of this formula, we can calculate the E naught of the electrode under test. The direction of the flow of the current will predict whether the electrode will act as anode or cathode. That means whether the electrode will undergo oxidation or reduction. Now let us discuss the determination of single electrode potential using the standard hydrogen electrode, whose abbreviation is SHE. If we couple an electrode with the standard hydrogen electrode using the salt bridge, and the electrode under test pushes the electrons into the external circuit, let the potential measured be 0.76 volts. Also, we know that the potential of the standard hydrogen electrode is 0. So, substituting the values of SHE and the electrode potential which is measured, that is 0.76 volts, in the formula E naught cell is equal to E naught cathode minus E naught anode, we get the electrode potential under test electrode as minus 0.76 volts. Here I have explained how it is coming minus 0.76 volts. So this shows that the minus sign represents that the reduction potential of the electrode is minus 0.76, which is the electrode potential of zinc, and also that this electrode is acting as anode. So we can write the cell diagram as under zinc in the zinc ions, salt bridge, and then we are writing the SHE electrode on the right hand side. The half cell reactions of this cell can be written as at anode, the zinc will get oxidized to produce zinc ions with a loss of 2 electrons, and at cathode, the hydrogen ions will accept these 2 electrons coming from the external circuit to get reduced at the cathode as hydrogen gas. And here I have mentioned the net cell reaction also. So this is how we can calculate the electrode potential of a given electrode under test using the standard hydrogen electrode as the reference electrode. and also we can determine whether the electrode is acting as anode or cathode. In the next example, we have taken an electrode and coupled it with the SHE using a salt bridge, and in this case the potential of the cell is measured as 0.34 volts. Again we will put the values in the formula. E naught cell is equal to E naught cathode minus E naught anode, and we get the E naught for the electrode under test as 0.34 volts. Now this sign is positive, and we know that the positive sign indicates that it should be acting as cathode. Also we know that 0.34 volts is the electrode potential, reduction potential of copper. Therefore, we can write the cell structure as represented here by taking the SHE on the left hand side and the electrode under test, that is the copper, we have already determined by the reduction potential of the electrode that it is copper electrode, writing on the right hand side. The half cell reactions will be at anode. The hydrogen will dissociate to produce hydrogen ions with the loss of 2 electrons. These electrons will be accepted at the cathode, and the copper ions in the solution will get reduced at the cathode, and the net cell reaction is also written here. So this is how we can determine the electrode potential of a single electrode using the standard hydrogen electrode. We can also determine the single electrode potential of an electrode using saturated Calomel electrode. So we know that saturated Calomel electrode, SCE is the abbreviation for it, has a potential of 0.2422 volts. I have written here. So using a salt bridge, we will combine the two half cells, connect the two half cells, and we will measure the potential. Let it be 1.002 volts. So again we will substitute the values of the saturated Calomel electrode and the measured potential in the formula. E naught cell is equal to E naught cathode minus E naught anode, and the calculated value of the potential of the electrode under test is coming out to be minus 0.76 volts. So again minus 0.76 volts is the reduction potential of zinc. So we can conclude that the electrode under test is zinc and it is acting as anode. So this is how we can calculate the single electrode potential using the reference electrodes such as SHE, standard hydrogen electrode, whose potential is 0, and SCE, that is the saturated Calomel electrode, whose potential is 0.2422 volts. In my next lecture, we will be talking about the different types of electrodes, half cells, and also the various types of reference electrodes. Thank you.